Good morning, students. Today we are going to start chapter number 1, real numbers. What are real numbers? Real numbers means it's a combination of rational as well as irrational numbers. You know that what are rational numbers? The numbers which can be written in the form of P by Q, and irrational numbers means which cannot be able to write in the P by Q form. Some examples of irrational numbers are root 2, root 3, root 5, etc. This chapter consists of two main things about real numbers. First it is Euclid's division algorithm or Euclid division lemma. Second, fundamental theorem of arithmetic and its applications also there. But this year, Euclid's division algorithm, that topic is a deleted topic, so no need to study. So we can continue with the topic fundamental theorem of arithmetic as well as its applications. Now, what are the applications of fundamental theorem of arithmetic? Where we use this fundamental theorem of arithmetic? We use the fundamental theorem of arithmetic for two main applications. First, to prove the irrationality of many of the numbers you studied in 9th standard, such as root 2, root 3 and root 5. Second, we apply this theorem to explore when exactly the decimal expansion of the rational number, say P by Q, is terminating and when it is non-terminating repeating. Consider a composite number 36. I am going to write this 36 as product of two or more numbers in different ways. You can write now in different way 36 can write. So first way 36 equal to 9 into 4, then 6 into 6, then 12 into 3, then 36 can write, you can write it as 2 square into 3 square, or 36 can 3 square into 2 square, or 36 1 into 36. Different ways of expression of 36 expressed as a product of two numbers in the different way. Here 9 into 4, 6 into 6, 12 into 3. 9, 4 are not prime numbers, 6 into 6 are not prime, but 12 into 3, 3 is a prime number, but not 12. Then what about this middle two cases? That means 36 equal to 2 square into 3 square and 3 square into 2 square. What is the specialty of these two cases except out of these all things? In this expression, only prime numbers comes. Or 36 we rewrite as the product of primes only. So I am writing that once again. That is 36 2 square into 3 square or 3 square into 2 square. These two cases. This is the factorization of 36 as well as prime factorization, because here it involves only prime numbers. If like this, that is a factorization only involves prime numbers, that is prime factorization. How many ways other than these two ways? Is there any other way to write 36 as product of any other prime number? Is it possible? Except these two ways. 2 square into 3 square, 4 into 9 or 9 into 4. Both are 36. Then in that previous case, 9 into 4, 6 into 6. These are all factorization but not prime factorization. Only two primes here, 2 and 3. Then this is the only prime factorization of 36. That is, prime factorization is unique. So, which is the number 36? 36 is a prime composite number. We express that composite number as product of primes in two ways. One is 2 square into 3 square. The other is the opposite way. That is, what is the difference between these two cases? Only the order change. So, this is fundamental theorem of arithmetic. That is, every composite number can be expressed as product of primes. Or you can write as a prime factorization. That is unique. That prime factorization is always unique. That prime factorization is always unique apart from the order in which the prime factors occurs. Fundamental theorem of arithmetic statement. Every composite number can be expressed or factorized as product of primes, and this prime factorization is unique apart from the order in which prime factors occurs. This is a statement of fundamental theorem of arithmetic.